if I have like 3 to the x, hush, equals 9, what would x have to be right there? 2. Because 3 squared is 9, right? 3 to the second power equals 9. So 3 to the what equals, let's say 27. Or negative 27. Whoops. Screwed up. Negative 3 to the what is negative 27? 3, right. 3 to the third, 3 times 3 times 3 is 27. Okay, this is the one the class gets wrong. 3 to the what x equals 1/9? Negative 2, right. So what a negative in the exponent does is it just flips it upside down. So 3 squared is 9. So 3 to the negative 2 is 1/9. Okay. Now, that's not the new thing. So the new thing is more like this. 3 to the x equals 10. How would I solve that? Well, no, there is no square root, no cube root, nothing. But there is a button on the calculator that can help us out here. Well, I don't know exactly what it is, but I know it's going to be a little bit bigger than 2 because 3 squared is 9, right? So the answer we should expect is about like 2.2 or something. It's a little bit bigger than 2. 3 to the third is 27. 3 to the second is 9, so it's probably 3.1, okay? But how do we figure out exactly, as exactly as we can? Well, there's a button on the calculator. It's called the logarithm function. There we go. Logarithm function, or log for short. And it can help us find these missing weird exponents. So it's used to solve exponential equations just like this one, 3 to the x equals 10. Here's how it works. So here's how I usually explain it. Like, you think of these three values as a, b, and c. When you go to put it in log function form, okay, this is exponential form, like 3 to the x, and I'm going to change it to log form. It's going to be in this pattern. So log base a of c equals b. So it looks like this. Log base 3 of 10 equals blank, equals what? So what this means, it's like 3 to the what equals 10. And this is what we have to plug into the calculator to figure out our missing value here. So the order is A, C, B. You do the base first, so A stays in front, and then the big number, and then the exponent is over here that we don't know. Okay, now let's see if we can figure out how to plug this in the calculator. So, has anybody think they found the button yet? We have a little bit different calculators. Anybody not have a calculator? Okay. Anybody found the button? Where'd you find it, Grant?
Log?
Yeah. Okay, actually we don't want just the log button.
One up here?
We want on the most calculators it'll probably be close by, like I think it's upright or something. But there's like a blank here and a blank here.
Yep.
You guys see that button? Probably not on yours.
What is that?
Did you find the log button on yours though?
Not at all.
Did you find the log button, the normal log button on yours? Yeah. Okay, you can still do it with that. I will explain it here in a second for you. Or you can borrow the calculator.
That is for the YouTube video.
Okay, so let's all try plugging this in. So remember how I said it should be about 2.1. So let's see if we can all plug this in the calculator and see if we get about 2.1. Okay, Issa, on your calculator, you could also, the alternative is plugging in log of 10 divided by log of 3 instead of this.
What they do?
So it's, a couple extra button presses, plus it doesn't look exactly like this, so it's a little bit confusing, but it does still work. Okay, well, why do they have just this log button on your calculator? Okay, when they have just the log button, that is called a common logarithm, common log. And it's got an invisible base of 10 right there. So on our last problem we had a base of 3. That's what we put right there. So if they don't write a number in there for the log, that means the base is a 10. There's a little base of 10. So I feel like I'm doing this in the wrong order. This would be like 10 to the what equals 100. You guys know that? 10 to the second. 10 times 10, but it's 10 to the second is 100. Okay. Does that make sense? If you guys don't know what's going on, let me back up. Hush. Okay. So this means like 3 to the what equals 9. It's like the second. So this would spit out at 2. Okay? Because 3 to the second equals 9. That's kind of related. Anyways, let's kind of here. Let's look at number 1. Number 1, we are not solving this right now. Okay, they've already solved it for us, and we already knew the answer anyway. So it's just 5 squared equals 25. What they want us to do is turn this exponential equation into a logarithmic function. So what's the order? You do log, okay, base 5 of, and then you do this number on the other side, 25, and that should equal, like if we plug this in the calculator, 2. Okay, and that's it. All right, number 3. All right, somebody help me with number 3. Help me. All right, Grant.
Okay. And then we do the big number, which is 3 on the bottom. And then we do 1 9 over there. And then equal -2. Okay, yep.
So just a reminder, any number to a negative power flips value, right? Okay. Number 5. 10 to the 6th is 1,000,000. All right, somebody else besides Grant. Yep, that's right. Alright, you guys see the pattern? A couple of us do? Okay, we'll keep going around and see, make sure everybody's got it. I was gonna say, oh yeah, the book didn't write that though. You know what the book wrote? This. So why did the book just write that?
Because the log of 10 is implied.
Right. When it's just the common log and they don't put a number right there, the 10 is implied. Yes, like you said. So technically both of these are correct though. So, whatever, you don't have to change it. Number 7. Alright, somebody else. 6 to the 1 equals 6. Oh boy. Okay, sorry. Log 6. Oh, whoops. Number 9. Okay, number 9 is the opposite. We're starting with a log function and we're going to change it back to exponential form. Sometimes we have to do this to solve log equations later on. Let's see, who hasn't done one yet? Well, I haven't done one of these yet either. Maybe I should do one as an example. Or Shannon, do you know what it is? Or maybe I should do one first. Right. So both directions, it's still ACB, the order. So it's ACB. 3 to the 4th is 81. Yeah, it still works. And of course your answer makes sense, right? 3 to the 4th actually could be 81. It is 81. So that can help too. Number 11, log base 3. Alright. Is -6. Anya?
3 to -6 equals 1/729.
Yep. This would have been a really good Wednesday assignment. Didn't work out.
We should do it Wednesday next week. I did not.
Kieran, are you okay, bro?
What?
Caden, are you turning into the Hulk?
He gets mad.
You're a nerd, just like he is.
It's not here.
Hey,
Because
He's probably just got bad hair and like you do. Kieran, are you literally him?
Willow's like the Black Widow from. Never mind.
Number 13, would it be like just a 10?
Would
For
it be
the
one?
See, I find
Yeah, so they didn't put a base down there, so what's the base?
He might be building a boat.
10, you're right, yes.
Somebody say, what was our?
Yeah.
So,
You're like, wouldn't it be mine?
Ava, what would this one be?
What's that?
10 to the -1 equals
What's that mean? You just made it up.
Yep.
I said, I didn't mean
Whenever you see that, you remind me of that one dinosaur from Land Before Time.
shut up.
I've done that like once in my entire life.
No, I
Willow's
did that
weird.
before
We can
because
talk
I
about
remember
some
every
books.
single time.
Nope.
I hate Willow.
Yep.
Willis.
You know?
I used to watch that so much.
I love like the scene where like the even like the leaves.
That was a cartoon like when I was a child.
Listen, I love Land Before Time.
Listen.
You
no.
definitely, you were a dinosaur kid. You had dinosaur underwear and
Look
your
one
dress.
time.
You do like, I have dinosaur underwear and it matches my dress. Stop.
That's kind of embarrassing. I mean, you do you, but like.
You'd also
Not
be
that.
down for it. Oh, I wouldn't. Yes, you would. She would go. She would go. You know, I'm kind of like you're Christian, and in the olden days, we had to kill you.
We'll let you exist.
Issa, I bet you had a crush on one of the dinosaurs in Land Before
No,
Time.
I'm sure I did.
That would be literally Isabel.
I had a crush on Barrett.
Sorry. I respect you, dude.
Wow, look at you.
That's
Literally
Sharing
every
is
girl
not
in our
caring.
class did.
You should be ashamed of some of these things.
Honestly.
Okay,
I love the
15.
T-Rex. It's my favorite.
Is it?
Bro. Sorry, I have a reaction.
Forrest is gonna be lost.
Forrest is good.
0. Okay.
Get a load of this.
Did I write this one?
1, -3.
Forrest, look what we're doing.
0.000.
Oh god. Okay, you should. Just should.
We're doing
Wait.
all.
The boats in the
Wait, did I copy that right?
Oh, wait.
It's a positive 3.
Yes, positive 3.
Oh, I did copy it right. I don't know what I was thinking. Okay. Number 7.
I've already done all those questions.
Issa.
She was singing 2 seconds ago.
Okay, but I stopped.
Doesn't mean you
And he hit
can.
you.
This.
Notice how everyone else is still singing.
So you just put
You'll get
You've
I would be
you've warned my patience.
confusing.
No. Kill them, Mr. Jordan. Alright, so basically, you take the number, you put it in the target spot. Shut up. Play that.
All right, who hasn't done
In
one
the
yet?
baseball.
Anya.
It'll give you the-
Anya has not done one.
Yes, she
Anya-
did. She did one
Already
right.
all-
Eva has it. Eva has
You're a fatty. You're
I've
a
done this
fatty.
whole finding game.
It's so easy.
Okay, actually, this one has a little note we need to talk about.
Oh no.
Number
Uh,
17.
Caden, what would this one be?
Because one
Would it be like would the 1/4 be in parentheses because it's the whole thing?
Yeah, that's the problem. If I just do it like this, why is this wrong?
Because it wouldn't work.
Because it looks like we're just cubing the 1, and that's the problem. So how do I cube all of that?
Parentheses.
Parentheses.
What's
Yeah,
the
so
same with the other one?
if there's another fraction like on
God bless America.
18.
18,
Thank goodness that person was in here. I see you're learning a few things, Kate.
I will summon the
Is
attacker.
the B section just like?
I'm gonna hit you with a chair.
almost.
No.
I mean, I think they wanted you to try to do it without it.
Running golems.
Like, I don't think they expect you to know how to use a calculator on this part yet. Guys,
But you'll let us use the calculator, right?
I like
kind of. Some of it you can't use a calculator. Like 27, for example, 28, all those, the last ones.
I would not suggest that.
Okay,
Singing.
let's pick back up at 23. And I know you guys are doing the evens, you need to stop and pay attention. Some of these odds cannot be done with a calculator, so we need to talk about how to do it. 23 could be done with a calculator, but I want to see if you guys can figure out without one. So 3, I kind of talked about this at the beginning. 3 to the what? 3 log base 3 of 127. Okay, equals blank, right? Like question mark. So I'll put an X out here. What would this be if I changed it to exponential function? 3
To the something?
to the X to the blank.
One over.
Okay, so that's basically what this means. 3 to the what equals 127. That's what a log function does. Right. 3 to the third is 27, remember that? So this answer would just be -3.
Oh.
That's 23. 25. So, yeah, I skipped a couple.
Do you want us to show that work?
No. On 25, they didn't write the base, so what's the base? 10. So what 25 means is 10 to the what? Or we can put an X up there, I guess.
Yeah.
10 to the what equals, what was it, 100,000? 100,000. Do you guys know this one?
Wait,
Yeah.
10,000.
How many 10s do you have to multiply together to get to 100,000? 10 times 10 is what? 100 times 10 times 10. Yeah, each time you multiply by a 10, it just adds another 0 on. So this is like 5 10s multiplied together, so the answer is 5. Okay, now those two could have been done with a calculator, but 27 and the rest of them can't. Don't work. But they're not that bad. They're not that
Are
bad.
you serious? These chairs are gonna collapse because of you.
And I hope you go eat a croissant.
Okay,
What?
I'm wondering if anybody thinks they figured it out yet.
I have not figured it out.
Okay,
Is it B?
almost, kind of. You're on the right track. So they didn't say they didn't write this as an equation like we did at the beginning. So if I wrote it as an equation, it'd be like just equals what? So that's what we're trying to solve there. So if I change this to exponential form, what would it look like?
X equals B.
B to the x equals b. So that's the x is like a question mark. That's what this is equal to. So b to the what power equals b? 1. So the answer is not really b to the 1, the answer is just 1.
Wait, so do we answer this section with like something to the like power or just?
You just want
The
to
answer is
X
1.
equals.
Oh.
27.
All of them I switched the number and then like, I'm stupid.
1 is the exponent that would have been, but that's the answer. That's what we're looking for. Okay, 29, kind of similar and weird. Looks very similar. Log base b of b to the x is equal to what?
Yes.
Okay, I'm gonna put let's say we're trying to figure out what y is this time. Because they already used x over here, so I'll use a different letter. So what would this be in exponential form? B to the y equals b to the x. So what does y need to be?
X.
X. So the answer is actually just x. Yeah, the y thing I made up on my own, so it's not really in the problem. Maybe I should just put a question mark right there instead of a variable.
That paper was like, normal.
A little too easy.
It wasn't like.
Oh, we'll fix that next week, don't worry.
Please. Sure, let me. I don't know.
You want to
Oh, okay. I thought you were saying that's really easy. So that's